All right, welcome to part 3 of the Code Signal Arcade playlist. And today we're going to be starting from question 25, which, the first two parts covered questions 1 from 24. So let's just dive in on this new island. It's called Reigns of Reason for some reason. Okay, let's dig in. Okay, so it says, given an array of integers, replace all the occurrences of lm to replace with substitution lm. Okay, I guess it's pretty straightforward. So basically, like lm to replace means, okay, if it's 1, replace it with 3. Yeah, okay, makes sense. So we can just loop through the array and then just, if there is equality, then we just replace it, right? So basically, like for I in range, length of input array, and then if input array of I is equal to lm to replace, right? Yeah, lm, let's just copy this. Then input array of I is equal to substitution lm. And then we can return input array, right? That's it. So to make this a little bit cleaner, I think what I can do is instead of using range, I can just use enumerate, which allows me to iterate the array with index and the num. So basically, like index is here, num is here, so I can just use this as the num. It's equal to that. Then I can replace the array of I to the substitution element. So it's a little bit cleaner, not necessarily faster though, but a little bit cleaner. Let's just go with this. And yeah, so this one is solved in 11 minutes. That's weird. I guess I'm not sure why it says 11 minutes. I just solved it in like less than 1 minute, right? So, okay. Yeah, the time complexity of this would be O of n, and then space complexity, I didn't need any additional space, right? So that's that. Next question. Okay, check if all digits of the given integer are even. Okay, cool. Let's just start with like all even, like as true, right? And then if it is all even, then we just return true, and then otherwise it's false. I guess what I can do is not even that. Instantly return true, and then we can check each digit by using while loop, right? So if it's greater than 0, we can just say digit is equal to 10, and then if digit is not, let me just say 1, I guess. If the digit modulo by 2 is 1, that means it's odd, right? Then we can just return false. Instantly return false, right? And then we can say, okay, n divided by 10. And instead of writing this, we can just use this annotation. So that's that. And I think that's just, it should work. Okay, cool. Yeah, nice. And then the space and time complexity with this would be pretty straightforward. Space complexity, there's nothing, but in terms of time complexity, it's just the number of digits within the number, right? So basically, it's like the maximum is 9 in here. So basically, it will just loop 9 times, which is, you can say it's a constant time. Yeah, I would argue it's a constant time too. Okay, let's just move on to the next one. Okay, correct variable names consists only of English letters, digits, and underscores, and they can't start with the digits. Okay. Okay, gotcha. So this should be true. This should be false because there's a dash in here. And then this output should be false also because it starts with a digit. Okay, so we just have to check these conditions. So English letter, digits, and underscores. They can't start with a digit, okay? So let's just check. Okay, so the minimum length is actually 1, so we can check the first letter is digit, right? Then it's immediately false, right? So that's like the base condition. And then we can move on to checking each character. So for C in name, if C is al num, I think it's alphanumeric, right? So then we can just say, okay, continue. So these are like okay, right? And then what I can do is if C is equal to underscore, then I say continue as well. And other than that, I think we can just return false because it didn't pass any of the tests, right? So, and then return true. Okay, I think this should work. Okay, cool. So essentially, like I'm just checking, instead of also this, I can check like or like that, and then just use one if statement, right? Yeah, that works too. Okay, so I think this is pretty clean, I would say. Yeah, this is pretty clean. I would use this. Okay, this is good. And in terms of time and space complexity, this is just space complexity is constant, so there's no additional space. But in terms of time complexity, it's just O of n, right? N is the number of characters within the string. So that's that. Okay. Given a string, your task is to replace each of its characters by the next one in the English alphabet, okay? So replace A with B, B with C, C with D, blah, blah, blah. The output should be like that, okay? So I assume like Z goes to A, okay? How should I approach this? I guess I can use this as a ASCII thing too. Okay, so let's just do this. Response is empty array, so I'm just gonna be appending like character to the response, and then like return, joined version of this, right? So this is kind of like a string builder in a way. So let's just do that, and then for C in input string, so we're gonna loop through each characters, and then each character ASCII number would be ORDC, and then we can add +1 to it because that's the next number, right? And then just replace it that. So basically res.append like that. But there's like a problem here, right? The Z would become capital A or something. Let me just check real quick. So let's just quickly run it. Oh yeah, append ord +1. So this, sorry, yeah, this is gonna be a digit, right? So this is gonna give me like a ASCII number +1 would be like a digit, and then we have to convert it back into a character. And I think, how do I do that? ORD and I forgot. So I think I have to Google this real quick. ASCII to char Python. Okay, CHR. Okay, cool. CHR. I have to remember that. CHR will give me like a character representation, and then let's just run the tests. Okay, cool. So in here, return value is that. So what I can do is ch, that's the char, right? So the next char, I guess I can say next c, the next char. If next c is equal to this one, then next c would be a, right? Small a. And then I can just append that, and then this should work. Yeah, okay, so this works. But I think this is kind of like a really bad approach. Not necessarily like, and not necessarily bad, but I mean, I think there is a better way than this, which is, let's just print out the ORD of C +1, and then let's check the what's the Z value, right? So Z is CRAZY. Okay, so the Z is that 123. Okay, so essentially what I can do is, if it's 123, I can, I guess it's not that bad approach. There is like a way to do it with one line too. So I'm just trying to do that essentially. 123. If it is greater than, if it's 123, just replace it with like 98. That's what I'm trying to do basically. Okay, I mean, this definitely works. I wouldn't say this is a bad solution to, but how should I approach this? Okay, let's just Let's just stick with this solution then. This definitely works, but I don't really like it though. Okay, ORD plus 1 is 25, 26. I guess I can do is like ASCII, or maybe index, ORD of A plus 1, and then or maybe it's the max, I guess. Okay, no. I think what I should do is this actually. Okay, I think I got it. 26. Okay. Index, and then ORD of A plus index. And then I can just instantly do this. And then see if this works. Yeah, this should work. Cool. Okay, so what I've done is basically ORD of C would give me the ASCII number of the character, right? And then minus A would be like the number, the index of character A, right? Essentially, like character A would be 0 and character B would be 1, blah, 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 right? And then I'm adding plus 1 to it because that's going to be the next character. And then I'm getting like remainder of 26, right? So that's the idea. And then if it's 26, then it just goes to 0, which, wraps around. And then essentially I can replace this with that. And then, okay, gotcha. And then it's just going to be like one line. So I think this is much cleaner than before. And also this doesn't depend on like the curly braces, right? So I think that's also a bad approach because you wouldn't necessarily want to rely on like the Z, next character of Z is the curly braces, right? So this doesn't depend on that. So which is good solution. All right, next solution then. Okay, cool. Given two cells on the standard chessboard, determine whether they have the same color or not. Okay, so I think there is a trick to this question. So if you analyze the same colored board, right? So let's just assume A, B, C, D, E, F, G, H is a number, right? So I replace A with 1, B with 2, and C with 3, blah, 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 right? And then if you add the coordinates, right? 1 plus 1 would be 2, and 3 plus 3 would be 6, right? So every like black cell, every black board cell would be even, and every white one would be odd because it's like even plus odd. Yeah, even plus odd would always give you an odd number, and then even plus even would always give you an even number, right? So I think that's what it's called, like invariant or something like that. So you just have to recognize that, essentially. So let's do that. Let's just do like x coordinate is what? X coordinate is cell. Oh yeah, there are many x coordinate, right? Let's do x1 then. X1 is cell 1 of 0. And then what I can do is like take the ORD, which is the ASCII number, right? And then minus ORD of capital A and plus 1. So this gives me the first index, essentially. This one, and turned into a number, right? And then y1 would be just cell 1 of 1. And then we have to convert it into an integer. And then the same thing goes for the second one. So x2, y2 is cell 2, like that. Okay, so essentially like is even, right? So I guess, okay, what's the best way to solve this? Basically what I want to do is like, okay, yeah, okay, now I think I got it. Return x1 plus y1. Let's just check the remainder of each of these, right? 2 is equal x2 plus y2. like that, and that's it. So basically the remainder divided by 2 would have to be the same in order to be in the same cell color, right? So if you want it to be like on the white cells, then those two have to be odd. And then if you want to be on the black cells, those two, some would have to be even. So that's about it. Okay, cool. Yeah. And then obviously there's just no time complexity in here, right? So time and space complexity is just basically constant. Okay. Oh, okay. So the first island is finished. And we are doing good on time. So let's just go to the next problem. Okay, so what is this? Consider integer numbers from 0 to n minus 1 written on down along the circle such in a way that distance between any two neighboring numbers is equal. Okay, yeah. Given n and first number, find the number which is written readily opposite position to the first number. Okay. I see. So in terms of 10, there's like 10 points on a circle, right? And first number is 2. So and then in the opposite direction is 7. So just return that number essentially. And is n like integer? Yeah, okay. No, sorry, not integer, even. So there has to be like it has to be even in order to have like opposite corner, right? Opposite number. Cool. So I don't think this is pretty hard problem. It's just basically like if there's 10 points in the circle, then it's just basically adding the half to it, right? And then if it goes above n, we just have to wrap it around. So essentially like return n divided by 2 is going to be the half plus first number. And then if it's greater than n, we just have to wrap it around, which means I have to get the remainder, and that's it. Okay. And obviously in here, this space and time complexity would be just constant, right? All right, next question. Okay. You have deposited a specific amount of money into your bank account. Okay. And then each year your balance increases at the same growth rate with the assumption that you don't make any additional deposits. Find out how long would it take for your balance to pass a specific threshold. Okay. So I think the easiest way to solve this would be just simulating it, right? So you just basically do like a while loop and then iterate through a year by year and then make sure if it's greater than the threshold. So that's one way to do it. And another way to do it is just basically using math and finding out the number immediately, right? And I think using a logarithm would be the best way to do it. But let's just do the simulation first. Simulation. So essentially like let's just do like money equals deposit, right? So let's just do the current money, I guess. Let's just say current, okay? Current is less than threshold. And then we just do like year equals 0. So year equals plus minus 1 plus, so you just basically you get it to increase by 1, right? And then your current would be cur times rate. Rate would be rate plus 100 divided by 100. So that's going to be the rate, right? If it's 20%, it just basically means it's going to increase 1.2 times, right? So you have to do like this in order to get the number. And then return year. Okay, let's just do this and see what happens. Okay, it works definitely. So yeah, this is one way of doing it, but it's definitely not the most optimal, I would say. But maybe it is, but I think it's not that optimal of a solution. But it is a good solution though. So this is like one way of doing it. The other way of doing it is like using math. So let's just do the equation, right? So we have threshold has to be less than or greater than rate plus 100 to the n, right? Basically, like n is like the number of years that you want to do. and then times deposit, right? So this is the equation. So, and then n has to be large enough so that this inequality has to be true. So in order to do this, you just have to solve for n, right? So let's just solve that. So that's threshold divided by deposit. Let's divide everything by deposit. And then we have this, right? Okay, so now what we do is like make it a n square root, right? So now we have threshold divided by deposit and 1 divided by n square root, right, plus 100. Oh, I think I forgot to do the divide by 100 in here. So that's that. Okay, yeah, here. So now we still have divide by 100 here. Oh, wait, sorry. I don't think this is the way to go. You have to do logarithm in here to drop the n. You can't just do that. Your goal is to find the n, right? Not the rate. So in here, what I can do is like put log in front of it. And then, I mean, if you don't know log, then just don't bother with it. And then if you do know log, this might be like a, you know, kind of like a review, I guess. So you just put both sides on the under log, and then this exponent will be on the front, right? So times log of rate plus 100 divided by 100. So this is going to be your equation. And then essentially to find n, it's going to be, you just divide this up on both sides, right? So let's just do this divided by that. So this is your equation. So essentially you calculate this and then you can do like math.ceil to, you know, round it up. Or maybe is it math.floor? And we can find that out. I think math.ceil would break the inequality, but we want this inequality to be true. So I think math.floor might be the best then. So we want this inequality to be true, right? So I think calculate this number and then just use math.floor. And because there's a division there, you can use like a, I guess I don't need it. So this is fine. Yeah, this is fine. So let's just use this equation then. Okay. So using the equation, you have like the top part of the equation, which is threshold times deposit and has a log, right? But I think to use log, you have to import it from math, I believe. Math.log. Does that work? Let me just check. 0. Okay, it does work. There's no error, it seems like. Okay, yeah, it does work. And then the bottom is equal to this part. And then it should be math.log. And log is basically like, I think it's a natural log actually. So the base is going to be like e, right? So that's the default. And we don't really care about the base as long as it's a number. So a number other than 1, I think. So now I can just do top divided by bottom and then math.floor. Then I think that just should work. Oh, it didn't. Okay. Or is it? Or maybe is it math.ceil then? I thought it was math.floor actually. Okay, it's maybe, let's just try ceil. Okay, I guess it's ceil. That's weird. I guess you want this equation to be slightly true, right? But if you move it down, yeah, I guess ceil is correct because you want n large enough, like the smallest, but to satisfy this equation, right? But that's kind of weird though. Okay, never mind. I guess math.ceil works. So okay, so that's the basically the optimal solution. Okay, cool. Absolute values, some minimization. Okay, what is that? Given a sorted array of integers a, your task is to determine which element of a is closer to all other values of a. In other words, find the element x in a which minimizes the following sum. Okay, where a b as denotes the absolute value. There are several possible answers. Output the smallest one. Okay. I think there is a trick to this. I think the medium of the sorted array might give you the smallest one or something like that. Let's just try if that theory is correct, though. Just the following sum, or maybe not. Solution is 4. Okay, yeah, this is the median. This is also the median, I would say. Okay, so if length of a divided by 2 is correct, then return a of length of a divided by 2 minus 1, I think. And then other words, let me just return that. Is that it? Let me just check. Yeah, I think that's it. Okay. So I think this is just one of those things that you have to just be aware of it. So in order to minimize this sum, you just have to pick the middle number essentially. So that's how it works. But I mean, if you didn't know that, then I would just basically kind of like do a simulation, right? So just pick the first number, pick the second number, pick the third number, blah blah blah, and then just go until the end, and then return the minimum distance number. So I would just do that if you don't know this trick. So okay, cool. Strings rearrangement. All right, so given an array of equal length strings, you would like to know if it's possible to rearrange the order of the elements such that where each consecutive pair of strings differ exactly by one character return true. If okay, I see. A B B B A A true. Okay. All right, so this is probably like one of the harder problems in here. You're only rearranging the order of the strings, not the order of the letters within the strings. Okay. So this is a problem that requires a graph knowledge. So if you don't know anything about graphs, then I would highly suggest you learn about graphs. It's because like that's what you need in order to solve this problem. Because if you don't know it, then you're just gonna be like, what the hell is going on, right? But I mean, if you don't know it, then I think it is gonna be best not to get discouraged that much, but you can still follow along and see if you understand. But I'll try to explain it. So essentially, the idea is you have all these networks, right? So it says rearrange the character so that it only differs by one character, right? So that means you have a network. So for example, right, AB is connected to BB because you can switch this character to that, and that those are connected. And then BB is connected to, I think, well, what is BB connected to actually? Oh, wait. Let me just get the input array. I'll push it B2. What is if it's possible for exactly one character? Oh, maybe I was thinking wrong. Maybe it is not a graph problem actually. Because so AA is connected to BB, but also AA is also connected to like that. So but is this like optimally to so it is like a kind of like a graph that is connected, but I thought I was going to return maybe like if there is a path from one to another, but I guess it's not a problem like that. You have to rearrange it so that the every consecutive neighbors has one difference by one. Okay, so it's not solvable by graph, I guess. Maybe it is. But the thing is, you have to start from somewhere and end and visit every node that is possible, which is kind of dumb. Yeah, it's kind of dumb. So maybe solving it by array, no, sorry, graph is a bad idea. But there is one way to solve this for sure, which is basically like brute force method, right? And essentially you have to do it by brute force too. Kind of. It is to have like, generate all the possible orders and then just check one by one. Like, do these two differ by one? Do these two differ by one? So probably this is the hardest problem of code signal, like thus far. And you can see that this like count as well. Input length is 10. Okay, 15. Okay. Not sure if the brute force or the graph, like if which one is better though. If I do graph, then the starting location I should. Hmm. Yeah, but in order to generate all the possible combinations, I have to use like recursive backtracking, which I don't think I can do it out of out of memory, like by memory, by heart, which sucks. Maybe I can, but we'll see. Okay, let's just try it like the brute force approach, and this will probably take maybe like 20 minutes to solve, but we'll see. But essentially, like if you have all these combinations, you can just check one by one, and then you see if there is a match, right? If there is like a possible way of going from one to another. So that's it. So the first order of business is to generate a list of all the possible paths like this. So you have 3 inputs, you have 6, right? Basically, it's kind of like factorial. So I'll just say path is equal to generate paths input array. So generate paths would be a helper function that gives me the list of the paths. But yeah, this does require recursive backtracking, which I'm not really that good at, but I'll just try. I mean, I think I know the concept, but if I fail, maybe like after 10 minutes, I would have to look it up and then, kind of like cheat, I guess. I would have to look up like how to generate these possible combinations. Okay, let's start then. So I would have to return a list, but okay, so and then the array strings. So I know that I have to loop through all these numbers and then basically like mark the first one, and then do recursion and then mark the second one and then do recursion or something like that. But that's bad. Yeah, this is one of those areas I definitely need to work on. Num R, or maybe I should do enumerate because I need the index so that I can mark basically. Okay, so imagine that this recursion gives me like 2 ones. Okay, so we have this one. So I have to do that. that, and then that, and then every result should be a list to generate paths array of I plus array of I plus 1, like that, I guess. And then whenever there's the answer, so we have that. So it returns like a list of lists, which is for results in results auto depend, I think num plus result. Okay, result is already should be like that. Okay, but if length of R is equal to 1, that's the base case, right? Then return like R of 0, I guess. I don't know. Okay, so let me just try that and then see what happens. Paths turn false. Okay, runtime error, which is what error? Can only concatenate list, not string to list. Okay, what does that mean? Array. Input array is list of strings. Oh, this is actually S, I guess. So S. Enumerate array. Which line is this? Okay, num plus result. This one, right? Okay. I guess this should be result like this. Not sure. Okay. Okay, it does kind of work. But I think I have S is a string array. So it's like a triple nested thing, ABA. So, list of, maybe this should be like double list or something. No, wait. Yeah, maybe. Okay. So now it kind of is consistent, but I have to extract the list. Okay. Yeah, okay. Now this should work. Let me see. Okay, yeah, now it works definitely. Nice. Cool. So I got it. Nice. So I've generated all the possible combinations essentially. So the idea of recursive backtracking is that you have to mark like what you're trying to eliminate, right? So for here, in here, this is like the most crucial part, right? So you based on the index, you are marking the ith index as missing, right? So essentially, like I'm going to recurse, but everything but the current index. So that's the idea. So I'm taking the first I elements, and then the next elements, excluding the ith index. So this is going to be your recursion, right? And then the base case is pretty important too. Like if it's length, then we just return this. And the reason why I just didn't include this is because maybe it's just going to copy, not copy, the pass the reference of the array, and then it will mess things up. But let me just see if this works. No, it should be like that, right? Okay, yeah. AP. I guess it does work. Okay, so never mind. Then I thought there may be some weird case where I'm sending like a reference of the array, and that this will mess things up. But I guess this doesn't mess things up, so that's cool. Well, I guess it's because I'm already doing the copy like that. Okay, so never mind. Yeah, so basically just return the array if it's length of 1. That's going to be the only answer, right? And then exclude the number on the recursion, but be sure to add the excluded number back when the result comes in, right? So that's like basically the idea of the recursive backtracking. You're excluding it here for the recursion, then adding it back whenever there's a recursion like result comes in. So just keep that in mind whenever you're doing something like this. Cool. Okay, so now we have the generator paths, and then essentially you just check the neighbors, right? So for I in range, it's from 0 until input array -1, right? And then basically like if check strings input array of I, input array of I plus 1. Okay, so if these two are basically not true, then return false, right? So this helper function will give me like a result where if S1 and S2 differs by only one character, right? So that's the idea. So it should be like exactly one character, right? Okay, cool. For I in range, length of S1, if S1 of I does not equal S2 of I, then let's just do like count of 0, count increased by 1, then if count is greater than 1, then return false, right? Return true. Okay, so that's gonna be like checking the number of counts if it's greater than 1 or not. And then I think this is it. Oh, it didn't work, huh? Yeah, I wonder. So console return value is false. Oh, right. I just can't return false whenever there's a I have to actually like finish everything. I guess if this returns true, then return true, right? Immediately. Yeah, I think I was mistaken. So yeah, this is it. So whenever there's like a path, then it's like true, and then when everything is exhausted, then you just return false at the end. Ooh, it didn't work. QQ. What? Okay, so if there's QQ, then if it's exactly the same, okay, so instead of return true, count equals 1. Okay, I think that's it. It has to be exactly 1, right? Okay, so now this one is false. What is that? Why is that? Your return is true, expected false. Okay. BBB, BAB, ABA. Okay, let's just print the paths then. And then in here, print. Oh, I'm so dumb. I have to check the path. I didn't use the path at all. That's so funny. Okay, for path and paths. And then instead of input array, yeah, it doesn't matter. I guess I could just use this path I plus 1. Okay. I think this should work. Okay, it didn't. So wait, let me see. Paths, check string path I of path I plus 1. Expect your return value true. Check strings. Okay, let's just print the paths. Print the paths. And then in here, print path here. And make sure I know this is being done. Oh, wait. Well, what am I? Oh, yeah, this is path I plus 1. Oh, yeah. Oh, I'm such an idiot. Why am I doing this? This has to be true on all of the paths in order to be true, though. So I think what I was doing was kind of right. So if not, the beginning, if not, then just break, and then path can, I guess, what is it called? Rearrange, I guess, can tell message the way to consecutive pair numbers to can, well, this is a can connect. So can connect is true initially, and then in here, obviously can connect would be false because there's no path way to do that. And then in here, after the break, if can connect, then return true. Otherwise, return false. Okay, so now this should work. Let's see. Oh, it should what? Return break. Okay. Okay, now it worked. Nice. Cool. So yeah, I think I was just doing some stupid stuff. So essentially, like we have backtracking, and then we have checking two strings, and then this will check every possible like every neighboring strings if it's deferred by 1, and then if one of them connects, then just return true, right? So that's it. There is like an optimal way to do this, I would say, to generate the paths. Like obviously you don't have to generate every path, right? Because like, for example, like this and this is obviously not correct because this is deferred by like 2 or something like that. But that I don't think this is like worth it on this problem at all, because this is already going to give you like so much time complexity, like, right? It's like n factorial already. So to generate these things, and then like small optimization wouldn't make that much of a difference, but in practical sense it will. But but in terms of time complexity, this is going to be n factorial. And then this checking key strings is just n, and then this is just going to be n factorial times n, I would say. So yeah, I think that's the time complexity, and space complexity is also n factorial. Okay, that's about it. And then yeah, let's just submit this. Cool. Okay, solved without hints, 32 problems, which is more than average of 15. Okay. Yeah, I didn't use hint. Is that the finish one? Okay, cool. Yeah, let's just stop here for now. I think this is a good place to stop. And then I've basically finished like 2 more islands on part 3. And then yeah, I'll see you on part 4. And then be sure to like and subscribe and leave any comments, questions, and suggestions down below. All right, see you.